Thanks for joining, everyone. Your presenter today is Adam Mitz. Adam is a principal software engineer here at Object Computing, and he is the technical lead on OpenDDS. And with that, I introduce Adam, and I will let you take it from here.
Well, hi everyone. Thanks for joining. As Nikki said, this is Adam, and we are very excited to share with you what's new in OpenDDS. Version 3.14, as many of you have probably seen, was just released a little while ago. I think about a week and a half ago or so. And a lot has been updated in OpenDDS. So we hope that if you are currently using an older version, you'll update to 3.14, or if you are not yet using OpenDDS, this is a great time to start. So our agenda for the webinar today, first, just a little bit of background and review on OpenDDS, as a project and kind of its background. And then we'll talk about a number of the new features in this release, and we've kind of categorized them here, as you see in this outline. Those that improve the developer experience, those that are there to help platform support and platform integration, features for deploying DDS applications across the public internet, and features that enhance performance and scalability. Then finally, we'll wrap up with some of the other changes that didn't fit nicely into one of those categories and some concluding information and next steps. So as Nikki said, questions are welcome. So please post questions at any time. So we need to start with what is OpenDDS, just in case anyone is new to the concept here. The first bullet point is our general summary of what it is in a short version. So OpenDDS is an open source and widely adopted standards-based real-time publish subscribe solution for distributed systems. Lots of words there, hopefully not too buzzwordy, and we'll see what that means as we go on. So first things, just to orient us, the project has a website at opendds.org. And a repository that's hosted on GitHub under the Object Computing organization, as you'll see there. So, what kind of defines OpenDDS? What's its overall requirements? Well, it's there to implement the data distribution service standard, which comes from the Object Management Group. But there's a lot more than just what's in the DDS standard. There's interoperability with other DDSs that is achieved through the standardized wire protocol, also known as DDSI RTPS, and additionally support for DDS security, and new to this release, some of the X types features, extensible and dynamic topic types. OpenDDS, just as a software project, just to give a little bit of history and overview, development started with our team at OCI back in 2005. Version 1.0 was released in July 2007. That's where it got the name OpenDDS. Version 1.2 was released a little over a year later and added Java bindings. So, primarily developers using OpenDDS will write applications in either Java or C++ to make use of all the middleware features in the product. Just as a software artifact, there's about 17,000, well, greater than 17,000 commits in the Git repository. They come from our team at OCI, but also from community contributors. The GitHub repository is the active development repository. It's not just snapshots or releases that get posted. So if you follow the repository, or at least follow releases on the repository, you can see all the development going on. There are continuous integration builds to automate testing on many platforms and compilers, and there's kind of two different support models around OpenDDS: community support and commercial support. So community support, it is a completely open source project, so it's got opendds.org, which all the source code for that is in GitHub and available. The issues and pull request system of GitHub, and then since GitHub doesn't yet, or maybe never will never host mailing lists, those are still hosted by SourceForge. And commercial support is provided by OCI. So our team at Object Computing will provide custom development, support, training, consulting around all of the open source code. So that's just a real brief kind of look at OpenDDS as an open source software project. We wanted to list, and I don't know that we've ever actually pulled these together in one place before, which we will be updating the website with this quite soon. We wanted to list what we're calling here complementary projects. There's been a lot of kind of other development around OpenDDS, especially over the past few years. And so, as you see from these links, this code for these different projects they're hosted in different repositories. They're not, part of OpenDDS proper, but they're designed to work with it in various different ways. And so, they have those first two are all about kind of binding to different languages and runtime systems, right? So Node.js for JavaScript, C Sharp for the .NET runtime environment. There's also support for Yocto, also known as Open Embedded, and Python bindings, which is still a very early phase of development, but it's there, and we're excited about kind of getting some more momentum behind that one. And ROS2. So if you are involved in robotics at all or robotic type distributed systems, you may have heard of ROS, Robot Operating System, and that ROS2 is built on DDS as kind of the core of its middleware, of its data distribution. And so ROS2 support for OpenDDS is currently in development at those repositories. So those aren't part of really the 3.14 or really any release, but I think it's good to mention that all those things are happening to acknowledge great contributions from across the community, both within OCI and externally. So here's a diagram that we've used before if you've attended any of the other webinars to kind of give just a real high level overview and to talk about some of the DDS terms and concepts, right? So when we're putting together a DDS system, we have this distributed publish and subscribe interaction, right? There's any number of data writers that supply data into this abstract notion of a global data space, and decoupled readers from that receive data, and those get matched up based on their topics, right? So mostly what we're talking about today is kind of these features in OpenDDS in this latest release, but it's good to keep in mind, um, you know, what context this is in, right? How we're using it. We're using it to construct these distributed systems that share data over this data-centric publish-subscribe mechanism. So how does OpenDDS actually implement that? Well, if we kind of could sort of think of this as taking a bit of a cross section of parts of that previous diagram. If we look at two different applications, A may just for a simplification, maybe A here on the left only publishes data and B on the right only subscribes to it. And we can see that they have a few different layers, right? There's the DCPS layer, data centric publish and subscribe, involving all those things that we saw as kind of the API that the application uses to interact with DDS, like data writer and topic and the quality of service policies. Then underneath, as you'll see in the lower part of the diagram, OpenDDS has concepts of transport and discovery that are configurable. And similarly here with application B, right? So it needs to subscribe to data and it has its own instances of transport and discovery. So we'll see some of those terms come up as we get to some of these details, right? What improvements are happening in the transports and the discovery modules, and in just kind of the general DCPS as well. Okay, so let's start getting into the actual features that are new to 3.14. And this first category is about what we've called here improving the developer experience. Because one important part of OpenDDS is how an application developer constructs their application using both the libraries that are provided with OpenDDS, but also the code that's generated from IDL. And so our first major feature here is Xtype's IDL annotations, which does allow one to use IDL files across different DDS implementations. But if you're not doing that and just using OpenDDS, this is still a very important feature and useful and powerful. So we'll see an example of that in a second. The second one is support for the IDL to C++11 language mapping. We've always had the IDL to C++ language mapping, but now this is an additional option for code generation. And we'll get into some of those examples in a moment also. The next one is the CMake module. So many projects that use OpenDDS are built with the CMake build system. And starting in this version, OpenDDS provides uh, the CMake code necessary for a project using OpenDDS to run that find package command, right, in CMake to say, I want to depend on or use OpenDDS and have the CMake system know about where how to invoke code generators, where headers are found, where libraries are found, all of those things that it needs to do. And the last one on this list is rapid JSON code generation from IDL. So you'll see JSON come up a little bit later in this presentation as well. But here we're just talking about essentially kind of a lower level feature where if you'd like, kind of external communication, like non-DDS communication, if that needs to be JSON formatted data, the OpenDDS IDL compiler can generate code that will use the rapid JSON library to convert to and from JSON documents, right, with these corresponding IDL generated types. So if that's something you need, please definitely check it out. If that doesn't make any sense and you don't use JSON, then feel free to ignore it. So let's dig into the first of these topics, the Xtypes IDL annotations. And so here's our before and after picture, right? Before is what we've done previously with OpenDDS with those pound pragma lines in IDL, right? And those pound pragmas were, not part of any IDL specification. That's why it uses that pragma notation with the preprocessor to provide this additional information to the code generator about the fact that we need to generate code for this structure, and here is the key that we're going to use within the structure. And you'll see on the after side of this slide that this is much simplified with Xtypes IDL annotations. So the idea of an annotation is that it starts with an @ symbol and then has a simple identifier like topic. It could also maybe have some additional parameters after that, but we don't need it in this simple example. Here we're using topic and key, right? Those two bold annotations that are shown here. And so this is standardized, in the IDL4 standard and the Xtype standard. So doing this is kind of common across DDS implementations, and hopefully just much simpler and easier to deal with. Okay, our next one of these features that we're digging into a little bit more is the IDL to C++11 language mapping. So on this slide, we're showing a number of we think of as kind of the IDL constructs, right? So what happens when you write in your IDL file an enum or a constant, a sequence, a structure, a union. And obviously these aren't complete examples. This is just a little overview here. But what we see on the right is for each of these IDL constructs, a little summary of what the code generator will generate. And this is generated by OpenDDS IDL when it's used in the C++11 mode, right? So the C++11 mode lets us make use of newer features in C++, both the language and the standard library, whereas the C++ classic mode, if you want to think of it that way, doesn't even assume that there is a standard library, right? So even things like standard string that have existed since long before C++11 were not actually used by that language mapping, and they are with this. So, this is an opt-in feature. So if you enable this option in the code generation, you'll get what should be a much easier to use mapping, in the sense that standard vector is used for sequences, standard string is used for strings. Um, Structures have a C++ class with a defined public interface, as do unions. And since this is C++11, it also has support for example, move semantics, right? Some of those nicer features that C++11 gives us. Even simply having the different constructors available here for the struct. For example, the default constructor and then also a member by member constructor are pretty useful. Okay, our next group of features is all about extending platform support and integration. So we can kind of think of, if you think of this sort of two-dimensionally, we can think of platforms support as kind of broadening platform support to make sure that different operating systems and runtime environments are well supported. Integration as kind of the deep side of that. Instead of going breadth first, it's going depth first, right? Saying how well does it make use of platform features, and that this first one is about that integration. So we've called it here responsiveness to network interface changes, right? So what happens when you have an OpenDDS participant up and running, and so it's set up transport to use various network interfaces, but those interfaces could change, right? It could be a scenario of joining or leaving range of a Wi-Fi network, or unplugging and plugging back in different wired networks, just changing which adapters are available, those sorts of things. So that is now supported on supported platforms. Going along with that is the second one on this list, the new built-in topic. So OpenDDS in this version has added a new way to report dynamic information about locations and connections up to the application. So using that same notion of built-in topics from the DDS standard, that there are the standard ones that are defined by the spec, but now there's an additional one, right? And what does this one give us? Well, it gives us information about what's happening internally in the OpenDDS transports, um, for which remote peers are associated, and what network interfaces they're using, and those sorts of things. So these next ones, starting with Android and going towards the bottom, are this the broadening platform support, right? So Android and iOS, we've had some Android support prior to this release, but we really increased Android support for this release, and done iOS support for the first time. We'll talk a little bit more about those in a moment. Java bindings now support JDK 12, so the Java development kits made a pretty major breaking change, I think, back in version 9 or so. And so OpenDDS now adapts to that and can build successfully with the modern versions of JDK. This includes working on both desktop and Android runtimes. Equals and hash code support are there for objects that get generated for the Java bindings, and some build system improvements have gone into that as well. And then towards the bottom of this list, just some kind of normal maintenance that we'll typically go through. So with these third-party dependencies that are optional, so if using the Qt GUI framework, also known as Qt, we are now on version 5 of that, and Wireshark is up to version 3. And I believe version 2, and maybe even back to 1 will still work backwards compatibly. Okay, a little bit more detail on mobile platform support. So for both Android and iOS, uh, We've done builds of OpenDDS, including DDS security. That involves, porting and setting up cross-compiling of ACE and OpenSSL and Xerces to make sure we get security working. There's just a few platform-specific bits in OpenDDS itself. Most of the platform-specific dependencies live in ACE. There are just a few minor things that happen within OpenDDS, so those are updated as well to support Android and iOS. And we've developed this example application. You see a screenshot from an Android emulator here, and that code is open source. So anybody who wants to see an example Android application can see it at that URL. I think coming soon will be equivalent example iOS application. And you'll see this application from the screenshot is what we called Smart Lock. It's just about having, this example of if you had network connected door locks, and for our example, we're just using Raspberry Pis with lights on them to say if it's locked or not. Uh, then this mobile app can control them, right? So it's showing the current state. Both of those are locked on the right there, and toggles to lock or unlock. So, we don't expect to win any UI UX design awards on this. It's just, there to be an example and to show that OpenDDS really can work well in this mobile environment, especially dealing with all those things that happen on mobile applications, like the application goes away or is backgrounded, or screen rotation changes, or network goes away and comes back and changes from Wi-Fi to 4G. So all of those kind of challenging, external factors. Our next group here is all about this idea of deploying DDS-based applications on the internet. Now, you don't have to deploy onto the public internet to really take advantage of these, but it's sort of a unifying theme here, right? So the first of these is DDS security. So until DDS security came along, there was really, no chance of kind of directly deploying a DDS application on the internet. It really wouldn't make much sense. But now with DDS security, that is a possibility. And new to this version is full message protection. So um, the DDS security spec, which there's another webinar for if you want to go back and review concepts from that, it offers sort of these different layers of protection, whether it's just the data payload or data payload with certain headers, but now full message is supported as well. So all those options are available to someone deploying with DDS security. The second of these is the RTPS relay server, and we'll talk a little bit more about this in a moment, but it's a scalable cloud-based helper for peer discovery, right? So what happens when we have two peer programs that are on different networks and their firewalls say that they can't directly send datagrams back and forth? Well, that's what this relay server is all about. And then working with that are two very interesting protocols that come from the IETF, the Internet Engineering Task Force, called ICE and STUN. And support for ICE and STUN is new in this version of OpenDDS, and they can work along with the RTPS relay to provide NAT firewall traversal and what I'm referring to here as multi-path resolution, right? So if two OpenDDS participants have different ways they can get to each other, for example, through different network interfaces, or with the relay server relaying their packets, ICE has a way of kind of resolving that. Which one do we actually use? And stun goes along with it. Stun is required for ICE, and it lets an endpoint discover its public IP address. So here's a picture of what this looks like, of what kind of a scalable solution looks like that can also deal with the fact that multicast is not supported across the public internet, and many devices will be restricted somehow, for example, behind a NAT firewall. So in this diagram, there are these two participants that are each behind their own firewall, and they want to communicate with each other. Well, the number one in the green arrow here shows if ICE is successful, they can send data directly from one to the other. That's one of the nice properties of ICE. But we're not guaranteed that that works. So the red arrows here with number two say we have a fallback option of sending the datagrams they need to exchange, bounce through an RTPS relay. There's sort of one other mode that we think of here, although it's not shown on this diagram, which is what if these two participants are actually behind the same firewall so they can communicate with each other? Of course, that's supported as well. So there's kind of these three modes of communication: directly or local, followed by the two shown here, right, using ICE and falling back to the relay. The relay itself, as I mentioned a little bit before, is a scalable server. What does that mean? Well, it means you can horizontally scale this to as many nodes as necessary for load and for high availability. What is it doing to actually implement that? Well, it's using OpenDDS because the RTPS relay needs some we think of as like routing information, right? Where are these participants located on the network? What GUIDs, global unique IDs are they using? And all that routing information can be tracked in DDS topics and is tracked that way to make the relay scalable. So not only is the relay a really useful tool in itself, I think it's also a very interesting application, and all the source code is right there in the OpenDDS repository uh, to say, what does it mean to use a DDS-based system to scale real-time data across a cloud resident service here? And we think that's been pretty successful. This group of features is enhancements to performance and scalability. So we've done a lot of work recently on improving performance, different aspects of performance, especially when the RTPS discovery mechanism is selected along with the RTPS UDP transport. And so there's a few sorts of improvements listed here, including reducing the latency for getting new associations started, more efficient use of messaging, which I'll show more details of in a second, and also this idea of kind of adaptive timing, right? There's certain messages are kind of in reply to another message, right? So there's a heartbeat, and then there can be an acknowledgement to reply to that, or a data that comes in, an acknowledgement for that. And so this version of OpenDDS is a little bit more adaptive about when those things need to go out fairly soon versus when they can wait for a timer interval. Along with these performance and scalability improvements is a completely new OpenDDS application that's in the OpenDDS repository called Bench2, and it's a performance and scalability framework. So Bench named after benchmarking. So the idea here, and we'll talk a little bit more about this in a moment, is about how do we set up a test system that we expect to have similar performance characteristics to our real production system in terms of a number of nodes in the system, what topics they're on, frequency of data publication, size of data, quality of service policies, configuration, right? All of these things sort of model a complete DDS system. And so the Bench2 framework lets us model the system and describe it all in JSON files, and then have a way to run that as a test and get results back from it. So we think this will be an excellent tool moving forward to kind of drive these decisions on where does performance need to be improved, where does scalability need to be improved. Well, we can actually run the system with Bench2, make relevant observations, and then tweak the code if necessary, and run again with Bench2 and see those results and hopefully improve. Okay, so we're going to dig into these kind of two major features one by one. The first of them being the overall efficiency and performance improvements in RTPS. RTPS kind of in general, referring to both RTPS discovery and the RTPS UDP transport. So one way to observe the improvements in 3.14 is to do a simple test, which I did. And so this one-to-one test is just, start up an application that only publishes one topic, start up an application that only subscribes to that same topic, and see how many messages they exchange for SEDP. Right? SEDP is the simple endpoint discovery protocol, one of the main protocols needed to accomplish discovery. Right? And by that metric, it's gone from 21 messages in the previous version to 16. So that's a significant improvement. The previous version of OpenDDS may need n-squared messages to associate n, so not really n participants, but dealing with the associations of n participants. And many of these performance improvements, even though we kind of measured this for discovery, uh, discovery makes use of the RTPS protocol. And so these are general improvements within, think of it as kind of the RTPS protocol engine that sits in OpenDDS. So they'll impact, all reliable readers, all readers that are actually using this. So two examples here that have these screenshots from Wireshark. The first one is the bundling of control submessages. So the highlighted line at the top shows that this single UDP datagram accomplishes these three different heartbeats, whereas in 3.13 those may have been sent separately, and so that kind of extends to the acknowledgments that you see below and to different message types as well. And the example at the bottom deals with this fewer data samples needed for accomplishing discovery. So the one that's highlighted in with that gray background that says it's packet number 22, that is an additional message sent by discovery for the reader, and that is not required at all. So 3.14 just won't send that. And that's a great way to make things faster, is to not need additional messages. So here we're looking at bench 2 in some more details. And so as I mentioned before in the overview, bench 2 is this benchmarking tool that's included with OpenDDS. And its overall architecture is like this. There's two different DDS domains involved. One is just for management, right? How to coordinate all this stuff. And the other is the actual test domain, right? So the workers, maybe, some writers, other readers, right? This can be any number of them, are exchanging data on the test domain. And the role of bench is to both launch those workers, which you see are child processes spawned by a node controller, and to collect results, right? To measure what actually happened when the worker did its task. So this is all run by the test controller. So there's only one instance of the test controller, and it uh, gets all the scenario information from JSON files, describe what we want it to do, distributes what needs to be distributed out to the node controllers, and also collects results back from the node controller and reports a results summary. So you see in the design of bench 2, we've been careful to separate kind of the management and operational sides of this, and to make it scalable, right? Because the management domain itself works on DDS. Any number of node controllers can be started on different virtual machines, physical machines, whatever testing is, whatever's doing the testing, and those can spawn worker processes. So some other features and bug fixes. So 3.14, obviously it's just a maintenance release of everything that's happened. I should say it's additionally a maintenance release of everything that's been happening in the OpenDDS repo since the previous release. So it has a number of different features and bug fixes that we've accumulated, including RTPS protocol is now up to the latest published spec, which is protocol version 2.4. There's some improvements to query condition and content filtered topic. There's better support for multiple transport instances, That's the case where those instances are used by the same writer or reader. TCP transport has some improvements for asynchronous connect and reconnect and timeout. There's support for publishing via the Node.js module. If you're wondering why it's listed here, although we talked about the Node.js support as being one of these complementary repositories, there's still code generation support for it within OpenDDS IDL. So that occurs within the OpenDDS repository. The inconsistent topic status is now supported with RTPS discovery. We have some improvements for large samples and improvements to presentation, quality of service, and the make install process. So this isn't a complete list, right? The news and the release notes on GitHub document everything that's been updated. Okay, so what's next? Where are we going from here? Well, first, additional X-types features are already in development, right? While just kind of general development continues, obviously with OpenDDS, we definitely wanted to highlight that X-types. It's a large spec. There's a lot in there, so we are kind of going to iteratively implement the parts that we think are most useful in that priority order. And of course, there's not much else that we can say definitively will happen in the next release because it's not necessarily up to us, right? So it's a completely open source project and it's going to evolve based on the needs of its stakeholders. So I know, a few people on this call are probably already represented on this list, and if you're not, we invite you to get involved with it. So we consider the stakeholders being users who sponsor the development efforts here at OCI, along with OCI's own investments in OpenDDS, and anyone contributing code or even non-code improvements, right? Documentation and issues and everything else that goes on in an open source project. And keep in mind community support mechanisms like mailing lists. The FAQ is available for folks to both read and to extend because all that code lives in GitHub. I shouldn't necessarily say code, it's just text and markdown, and submitting issues and pull requests. And commercial support, we provide all of these sorts of options for you, from design and architecture to development of features within OpenDDS or applications that use it, testing, analysis, integration support, training, and consulting. So please let us know if we can help you successful with OpenDDS. Some links where you can find more information. As I mentioned at the start, the OpenDDS project site is opendds.org, and the source code is on GitHub. If you haven't seen it yet and you'd like to see the Shapes demo, it is updated now for 3.14, and that is available on opendds.org. So that's a GUI application that shows shapes bouncing around the screen and how that data can be distributed through OpenDDS. A list of all the community support options are there at opendds.org, commercial support at objectcomputing.com, and there's two links to two previous webinars we've done, one focusing on DDS security and another about designing distributed applications using the quality of service policies. If you want to list some upcoming events, if you're watching a recording of this later, then they're no longer upcoming events. But here's what we're looking at within the next month or so. So the Object Management Group's quarterly meeting is coming up March 23rd to 27th. It's happening completely online, so more information can be found on their website. We'll be participating in that. And there was a DDS-focused public event that was originally planned for in-person in Reston, Virginia. It'll be sort of fractured into some different discrete events that will be held online and publicly available as well. We are hosting another Introduction to OpenDDS online training session coming up in April. So if you're new to a lot of the topics we talked about today, or folks on your team are new to it and want to just get up to speed quickly with writing programs that use OpenDDS, this is a great option. that's coming up starting April 14th. And we'd like to offer other training topics in a similar format. So we have a survey. You'll see the link at the bottom here. So if you're interested in the idea of online training, but the introduction of OpenDDS is not something you need because you already know it, then please take a look at that survey there. And I think that's all I've got, Nikki. Please go ahead.
So we'll go ahead and we'll wrap up here. We look forward to hearing from you on the additional topics that you would like to learn about related to OpenDDS. Thanks everyone for joining. Have a great rest of your day.
All right, thank you. Thanks, Nikki.